And before I dive into anything around the tools and processes, I kind of want to touch on just the initial of where do you start when you're debugging? And where you want to start is you want to start with finding the problem. So one of the first steps of finding the problem is you want to gather details. And one of the most important things you can do is you want to consider what should it do when it is successful and what is going on with the bug. So here's another mistake that I have definitely made many times. How many of you have fixed a bug and then you push it up to production and something else went wrong because you didn't know what it was supposed to do? That's something I've done. Push up a bug, having no clue what it's supposed to do, you're like, oh, I fixed it. That same thing is not happening, and now you have something else happening. Especially common if you're working with legacy order code, your code's spaghetti mess, that will happen. The other thing you want to do is just ask if others have ran into the problem and what has changed recently. So you want to try to get a sense of, has one of your teammates seen this? Has this been reported before? That can give you a lot more information of like, oh, we already have a bug, we've determined it's not high priority, we can let it go, and we don't have to look at it right now. The other thing it can help you with is, yeah, we actually have a wiki or support instructions on, here's exactly how you fix it, here's what you can do for now to handle this problem. Then you can also look at what changed recently. Was there any recent code deployments? Any recent changes in your own databases, the server, hardware, networking, working with web apps like I do? Any changes in any of those could possibly be the cause of what went wrong. So a good first step is just figure out what changed recently. If the bug only started happening today, what changed today? Did something change yesterday that it only showed up now? Just figuring out what changed recently is a really good thing to do. Now that doesn't mean the bug always is from something recent. You can have those bugs that someone never hit that use case or that scenario where it's been around, that code just caused an issue, it's been around for 2 years, and all of a sudden today is decided to blow up and cause that issue. I actually have my old manager, I like to pick on him because he was down on his honeymoon down in like Jamaica or somewhere in one of the tropical islands, and the site he was working on, it was brought down by a query that he wrote 2 years ago. Then all of a sudden they hit a scenario, the query plan changed, and started crashing our whole entire admin site. So you can have something like that 2 years ago, code you wrote, bring something down. So usually something recent, but don't always just assume that. I like to always pick on that with breaking while he's out on honeymoon, not there to fix it. Another good third step is identify your device, the environment, and system information. This is especially important if you're working on something like web applications, mobile applications, anything where it might be running on different hardware, different software. How many of you might be web developers in here, or even mobile developers? So we all know then, most of us, that sometimes our problems are something like, if we think back, Internet Explorer did not like to play well with a lot of stuff, and that could cause a lot of issues. It could be a specific browser or something like that. So it's good to know where that error is happening. So, if you're your web developer, you go to recreate in Chrome, you can't recreate it. Well, was your user in the same browser? After you gather all information, you want to try to reproduce the bug. And you want to try to reproduce this in the lowest environment possible. So if it's happening in production, try to reproduce it on your local computer. If you can't do it on your local computer, if you have a dev or a test environment, QA environment, somewhere else you might go to reproduce it. Again, the reason you just want to do that, you have a lot more options to be able to use. It's a lot easier to debug it in a lower environment than it is in production where your customers and your users are. You also want to reduce the steps to reproduce it to the minimum steps. So if you're figuring out the bug and you figure out how to reproduce it, but it's 10 steps, can you get that down to 5? Can you get it down to 2? Can you get it down to the minimum number of steps that cause it? Because that's going to speed up testing your fixes, testing what's going on. That's how you can get a lot quicker at getting to the root cause and solving the actual issue. And another thing you want to be able to do is you want to write tests when able to. Now, how many of your systems here do you have automated tests for, right? Writing stuff for? I'm going to raise my hand about halfway because systems I work with, some have none, some have, and some are pretty good on it. But if you can write tests, write a test for the bug. You can write what's called a regressing test, where you write a test that causes that bug to happen. It's failing, it will fail when that bug is hit, so then you keep fixing the code, keep running that test. Once the test passes, you know you fixed the bug. That's a really good way to be able to quickly fix a bug without having to manually go into your app and change things and run through 10 manual steps to do it. If you have an automated test you can do that reproduces it, that causes it, that's a really quick way to do it. Plus, you're going to stop that bug from reoccurring again. If someone changes code 3 months later, or someone changes the database 3 months later, that's going to cause it to happen again. Your automated tests should catch that, and you won't have that go off production again. You won't cause the same issue. So we gather the details, so you know what's going wrong, you know what it should do when it's successful, where it's happening, figure out how to reproduce the problem. Another thing you want to be able to do too is you want to verify. So you want to verify that your environments are matching your code and your system. So especially again, you're doing local development, make sure you're matching what version you're working on, you know, of your branch. You're on, let's say you're deploying your master and main branch to production. Make sure you're testing against that if that's what issue is current. I can tell you, there's been a time I was fixing a bug, I probably lost about a day and a half. I was working against the wrong branch and the wrong system. Not a great experience to find out that I couldn't reproduce it because I was in the wrong area. And similarly, verify you're working in the correct environment. Again, another great mistake I made was trying to reproduce a bug and caused issues because I thought I was on my local computer and I was on the production URL and changed stuff in the production site. So make sure you're working where you know you are. Good tip to kind of do that and handle it is you can always add different colors or frame icons or something to indicate what environment you're working on, especially working on web apps or some kind of alert that might tell you, hey, you're in the dev environment here, you're in the safe area. So that's the first core thing you need to do when you're thinking about debugging. Find the problem, gather the details, reproduce it then, and then verify that everything is working, or that verify you're in the right environment, verify everything's matching. But when you actually get into find the problem, what can we use to help us with that? And this is where debugging tools come in. So you have instrumentation type tools. So that is your login, your print statements, error and performance monitor tools that will gather information during normal execution. So for example, I have a screenshot here on the right of Sentry, which is an error monitoring program with a made up error in it. Cannot read property if my code is perfect or undefined. Apparently it's not that perfect if it's crashing. But you can use tools like this that will not only alert you that you have an issue, but they help you then track down what's going on wrong. We use Sentry where I work, and it's great because when an error comes in, we might already know about it, we might already be looking into it. We can then also dive into things like the stack trace. If you're not familiar with a stack trace, that's going to provide a trace of the exact path the code took and what methods were called. Typically, that's going to be automatically output with any error. Any good error monitoring software is going to automatically pull that stack trace, automatically display it to you. Most systems also have a way to automatically output the stack trace where you can look at it, whether that's your debugger, call a method. Stack trace is great. You can see what exactly did the code do, what methods did it call. That can really help with branching logic, things like that of, oh, did it hit this if statement and call this method or go this other way, how it might go there. Then you have your debugger, which is going to be one of your biggest tools to help you into debugging. This is going to give you insight into what's going on in your code without changing anything. But it also, especially like in web applications and other types of apps, you can change code and data in the middle of a request. Again, don't do that in production. You don't want to cause any issues by changing stuff if you're doing remote debugging. But locally, you can change stuff in the middle. And we're going to dive a lot more into the debugger and how that might be able to help you closer to the end of this talk. But first, I want to dive into different processes you can use to help you debug. So I remember when I started off debugging, and I see this a lot from a lot of the devs I work with, until they get better at debugging, is they just kind of jump in and start trying a bunch of random things. They're not really sure where to look. They have that error come in, they're panicking or stressed out trying to get fixed quickly, and they don't really know what to do. They're like, okay, we have this error, but we don't know where to go. We don't know what to do with it. Another thing I see that is very common, and I've done this multiple times myself, is they're not keeping track of what they tried, and I haven't kept track of what I tried. So I have fixed bugs where I'm like, okay, it's fixed, it didn't occur again, but I don't know what I changed, I don't know what actually fixed it. Not a great feeling. You can also waste a lot of time on it too, of you trying things and you finally reproduce it and you don't remember what you did to reproduce it. That can really slow you down. So keep track of what you tried, both things that worked and didn't work, so you don't waste time repeating yourself or not remember what you did. Another thing you can do too is you want to focus on finding where the problem is. And by finding where the problem is, you want to search until you find the root cause. So what the root cause is, it's the cause, the very first cause, root cause of the problem. So you can have bugs that cause other bugs, and that those other bugs will be symptoms of it. So you want to find that root cause, the thing that's truly causing it. Because if you fix just a symptom of it, you're still going to have issues occurring. So, you know, an issue of fixing a symptom might be something like your database gets bad data into it, and when you go to read it out, something's not working right, it's not correct. So you fix where it's reading out, fix it that's correct there. Well, your root cause is still there. Something's still allowing your data to be inserted into the database in a bad format. So that your root cause would be fix it, that bad data can't be inserted into your database. And that touches then on my last point there too, of don't only focus on code. Bugs can come from everywhere. They can come from your database. They can come from networking. They can come from hardware. We luckily, I don't think we've had anything like this happen in a very long time. I never had to do it because before I was really working in technology, but if you look it up, there was a time that Intel had a bug in one of their chips that messed up all floating point math on the chip. Who would have ever thought that your chip would be the reason that your math calculations aren't working right? But you know, don't always assume it's your code. It could be somewhere else. It could be a package you're using. It could be your framework. So you don't want to get stuck on thinking it's just your code. So these 4 points are important for all processes that I'm going to go over. At this time, I'm going to go over some specific processes and when they're good, why you would use them. So the first one would be backtracking. And what backtracking is when you're going to actually go through your code from where you know the error occurred and kind of keep going up to where you see it might have been correct. So this can be best for when you have a stack trace. You're already familiar with the code. So it's something you've been working on for a while, you know the project, you know the code. Again, you know what the code should be doing. Hopefully you know that for every bug you're fixing. Again, don't fix something you don't know what it should be doing, you might fix it wrong. There are some drawbacks to this though. The drawbacks are, it can be misleading because you're going to mostly focus on the code and you might not find that root cause because it's in the database or it's in the network. It can also be harder to find the root cause if the error you happen to be looking at is a symptom of a larger bug. So how exactly do you do the backtracking? You want to start at the last line of the stack trace or where you know the problem originated from. So figure out where did this problem occur, and then you're going to step upwards through the code. You can't really do this with a debugger, you've got to kind of do this reading through the code, but you're going to go backwards through the code of considering where did this go from being incorrect to correct because you're going backwards. This could also be something you might combine with the other processes. Maybe you can't really figure out how to do it with backtracking, but you use backtracking to figure out where the process started, what endpoint might have triggered it, or something like that. So it would be a really good way to help at that. And again, it's something you're going to hear me continue to remind because I do it, a lot of people I work on my team do it. You get to consider the outside factors. Get focused into, especially with like, I just deployed code and something blew up. You might get sucked into your code and that could be something completely different. So the kind of opposite of backtracking would be starting at the entry point. So this, again, is going to be best for kind of a different scenario because it's backwards of the backtracking. It can be good for user-reported errors. So you don't get something in your error management tool, you get it from a user. Or your error management tool has an unclear error message or a stack trace that doesn't really make sense. Or maybe you don't have a stack trace for some reason. Something went wrong there or wasn't set up right. It can also help if you're unfamiliar with code in the project. Because this one, you're going to kind of go from the beginning of where your code would have started, where that endpoint might have started from, and kind of step down through it. And sometimes I combine these together with backtracking. I might use backtracking to figure out where it started, but then use this process to actually figure out where it went wrong. The drawbacks to this is it's going to be harder to debug. You got to figure out where it actually started, where it happened. It can take longer because, especially if you have a longer, complex process, and this happened 10 steps into that process, you might be looking way up in your code way earlier, and that's just going to take you longer to get to where the issue actually occurred. It still requires knowing what the code should have done, and you also might end up going down paths the code didn't take too if you're going through it this way. So you might get to an if statement, a switch statement, take one path that the code didn't actually take when it had the issue, and then you have to go back, go down the other one to find the side that it was actually wrong on. So how do you do this one? Just like I mentioned earlier, reproduce the problem. So figure out how to reproduce the problem, but then you're going to step through your code with a debugger at the beginning area of where the problem started. So if it started on this API endpoint, call that API endpoint, have a breakpoint, and then just step through it. And you're monitoring the data and what the code is doing to where you see it go from, okay, on this step it was correct, on the next step it's incorrect. So what happened in between those two steps? What changed to make it incorrect? And that's how you can kind of figure out how that's wrong there. And I want to touch a little bit on, I'm going to go through this a little more later in the talk, but when I say step through the code debugger, I don't mean put 100 breakpoints in on every line and have it just keep stopping at every breakpoint. You have tools in your debugger to be able to actually step through the code and continue how to continue executing, which we'll talk a little bit about later on But I know, I started programming, I knew about breakpoints, so I put a breakpoint on every line, and that was really not that efficient. Another method you can do is problem simplification. So this is going to be best for, again, when you're unfamiliar with the code in the project. Complex code that doesn't require it all to run. So if there's areas that you know might be the cause of the problem or might not be, you can remove things. Stuff like you commented out, just have an odd ticket or return cross paths, something like that. This can also be helpful when other processes haven't helped. So you tried the backtracking, you tried the start of the entry point, you haven't been able to figure it out. The drawbacks to this is it's going to have to be done locally because you're typically removing code or in some way, with either comments or whatever. It's also not going to work if removing code will break things more. So if you can't remove any code and it's just going to blow up more, you can't really do this method. You also are going to have to do cleanup afterwards because you're changing the code to figure out what's going wrong. You're going to have to get the code back to its original state. Now, if you're using Git, some type of version control, that's going to be pretty easy because you can just do a Git reset, Git check out a different branch, go back to wherever you were. Though, remember to not have your fix in that, or you're also going to lose your fix. Get your fix out of there first, or do your fix later. This is still mostly a random process, so I'm not a big fan of that just because it's kind of like well, we don't know what's going wrong, let's just dive in anywhere, so it's still very random, that can be very time consuming. And you can also, this is a really big drawback and makes this not work at all, the bug might only show up when all code is present. There's a chance to remove the code as you're trying to simplify it that wouldn't work. So how do we do problem simplification? You determine what code you want to remove. Either remove code likely to or not likely to cause the bug. So you can kind of go either way of, I'm going to remove this code I think is causing the bug and see if it still occurs. Or you could be like, this is probably not causing it, let me remove it and see if it works. And then you just comment out or hard code those lines, and you repeat it until you find the problem. And you can combine this with other processes if needed. So you might do this with backtracking or starting the entry point, or what any other process we talk about. Most of these processes can be combined together. There's no reason you have to do only one when you're trying to figure out. Do what makes sense for the situation, the bug you're trying to solve. Another one is divide and conquer, which is just binary search. Hopefully you're already familiar with binary search, you know what that is. Again, this is best for complex code, unfamiliar with the code, unclear errors. Other processes haven't helped. One thing that is a benefit to this that the other processes don't have, you can do this with Git, using like Git bisect and Git lane. You can go what was the good commit and what was the bad commit. So if you know that this commit on Monday was working, but on this commit on Wednesday it's not working, you can use Git bisect to go divide and conquer, do binary search through your commits until you find the exact commit that broke it. Again, only going to help you if it's actually in your code though, so that's one of the drawbacks we're going to have here. This can take longer. You might end up looking at a lot of unrelated code. Like I said, if it's not a code, it's going to be harder to find. And you're usually going to have to use some other process with this too to actually figure out what went wrong. You need to be able to reproduce the problem. You need to use that backtracking or start at the entry point to figure out what's going wrong. This is more useful for figuring out when the bug was introduced and what is actually causing the issue. So the how for this, it's going to be, we are going to split the code into two halves. Debug the first half to see if the issue is there. If found the first half, split it in half again and repeat. If not, found the first half, split the second half and repeat. Same thing as a binary search through an array or a list. Same concept, split it in half, try one half. If it's there, split. Again, if not, go to the other one. That's pretty much same process how you would use binary search. Now there are some other processes that I'll go through quickly. These are much more you can use with the other ones, and not so much the exact steps to it is you do form a hypothesis. Just think back to science class, and this is a really good one to combine everything else. Make an educated guess of what you think the cause is. Then test in some way, whether with an automated test or manual testing. Is that the cause of the bug? Is that your issue? If it is, you now know what to go and fix. Another one we have is bug clustering. And this is very important when you have multiple things going wrong, and also helping to try to find symptoms and making sure you're also not focusing on the symptom. But if you're having a ton of bugs happening and a bunch of things are going wrong, so you have a bug that's causing other ones, you can group similar bugs together, then focus on only a single bug, a single type of bug at a time. So you're only going through one bug, one type of bug, instead of being all over the place, going back and forth between 5, 10 bugs, wherever it might be. You do have to watch out though that you're not focusing on a symptom rather than a root cause. Hopefully you can figure that out by what the type of errors are, or this might help you to quickly figure out, okay, this is actually likely being caused by something else, But especially depending on how your error reporting is, you want to use bug clustering if you're getting a lot of errors. If your errors aren't automatically getting grouped by your error reporting because the error message is slightly different or something like that, try to figure out which ones are related. Try to tackle the same thing as a single one at a time. Another one is rubber duck debugging, which, how many people here have heard of rubber duck debugging? Everyone know what that one is? Yeah, so you talk to yourself, a rubber duck, or someone else. So this is very helpful because most of the time you might answer your own questions. But to do that, you really do have to explain the problem as if you're talking to someone else. So if you're talking to yourself, talking to a rubber duck, your pet, whatever it might be, act like it's someone that's going to answer you. That's going to really help you make sure you stay and think of everything you need to. You want to include all details, assumptions, etc. This is going to be something that it is surprising how many times it helps you answer your own questions. And if they can't answer your own questions, hopefully they have an answer for you. And they can help you out there. But I can tell you there's been many times I struggled with an issue for a few hours. I turned to talk to someone, the back of the office, I could just turn to talk to someone. Now I have to send, shoot them a Teams message, Slack message. But you go to explain to them, and I'm like, never mind. I now know what I was going to ask. I now know the solution. So those are the processes. Now I want to talk about the debuggers. For the debugger, all my examples are from Visual Studio, but it could apply to JavaScript, anything else. Most debuggers have the same features. Python, Go, whatever you might work with, most debuggers, good debugging tools are going to have the same type of things. So you can have where you can set breakpoints. Hopefully everyone's going to have breakpoints. That's where you can have the code stop at a specific area, verify that a hidden area, some debuggers will support changing data or code there, or you can just look at what the values are. You have watch windows, which allow you to examine the value of variables while code is running. So you hit a breakpoint and look at your watch windows. Here's an example of an autos window from Visual Studio, where we can see what the values are of some of those fields, and I could even dive into those and look further at them. There are also advanced tools that some debuggers have. So Visual Studio has one that they call immediate window, which will actually allow you to interact with your code. You could call a method, you could call into a variable and change it or see what's stored in it. So some debuggers will let you call in your code. And the really nice thing that's nice about the immediate window style is you can call your code without it actually changing anything. And it can run separately of it. You can have a change of value. You can also say, hey, I want to call this method and see what it returns. As long as that method doesn't change anything, your debugger can return the value and not do anything. There's also advanced tools to look at threads and call stack windows there too. So I talked earlier about stepping through code. So in the upper right there, I highlighted what the commands will be in Visual Studio. You have step into and step out, which is where you can step into a method while your code is executing. So you can set a breakpoint, and then you can just tell it to keep stepping into methods so you can see what it does in that method, what's the next thing it's called. And that was something that, it's kind of like going through a video frame by frame. You're going through your code line by line. You can pause on each line without setting a breakpoint on each line. You just keep hitting that button. Most IDEs and debuggers are going to have a shortcut key for it. Allows you to quickly step through the code. If you get into a method, you realize this is going to be the cause or you don't need to look at, you can use the step out to go back out to where the code after that method was called and just continue executing. So it's a great way to quickly move through the code without a lot of breakpoints. You can also step over a method while still executing the code. So what step over does is it says, hey, don't step into the method and pause it. I don't care about seeing what's happening inside that method. Run it and just pause after the method runs. So that's if anything, learn how to use your step into, step out, and step over along with the processes from this talk, and that'll take you really far with debugging. A lot further than the console logs, print statements, things like that. These really allow you to move quickly through your code and see what it's doing. So there are other advanced debugger tips out there. So most debuggers support conditional breakpoints. How many here knew that you could set a breakpoint and tell it to only hit that breakpoint if certain conditions met? Anyone know that? How many of you actually use it? I know it. A lot less, yeah. That's kind of the surprising thing there. But it can be very useful. You can set a breakpoint, so if this value changes, I want you to hit it and let me know that it changed so I can pause and look at it. You can say this value is equal to something. So say you have a list of 10,000 things and you're looping through it. Well, you don't want to be pausing 10,000 times until you find the thing you're worrying about. You can set a breakpoint to say, I know this is occurring when the value is equal to Lancaster. So stop when it's Lancaster so I can examine it. You can also have it, as my screenshot shows here, of when a method hits so many times, pause it. So if you know something's happening like a recursive loop, or you want to check if a method's being hit and how many times, you can put breakpoints on that. Another thing you're going to have in your debugger, depending on what it is This is going to vary by your language, your platform you're working on. But if it's possible with your language and your platform, you'll actually be able to change code and values while running. So that you can actually pause your debugger, change what it's going to do, and continue. That's a great way. You do not always have to shut down, restart your process from the beginning, things like that. There are a few more advanced tips. I talked a little bit about the media window earlier, but this is an example of it. So having a list of companies, just go to display the first one, using a link in C#, list out the company properties, you can see it there. So this is a really great way, as I said, to interact with your code without stopping execution. You don't have to shut it down and start up again. You can just pause it like a debug breakpoint would, and you can see the results of calculations, variables, call methods. You can put kind of any random in there. If you wanted to, you put 2 + 2 and it'll give you the results. It doesn't, you're very powerful in what you are able to do. Most of the time you're going to use it to interact with your code, but you can do a lot in there without having to shut it down. Another thing I'm just going to touch on very lightly, because getting into debugging threads and looking at that, very complex, very hard, can be very hard to do, but most debuggers have the ability to be able to attach to and detach from specific threads and processes. This allows you to see what's happening in an individual thread, what the data is for it. So if you're doing anything with multi-threaded, parallel processing type of things, learning how to use your debugger thread tools can help you debug those individual threads, debug issues like that. Another thing I'm going to touch on is going to be just some more general debugging tips that can apply to anything. First one would be get help. Ask for help. It goes back to, again, ask if anyone else seen the problem. If you're stuck, you can't figure it out, ask someone for help. Google the problem. You might think it's specific to your scenario. Chances are it isn't. We all know how many answers there are on Stack Overflow, how much information there is on Google. Someone likely ran into your problem before, you might go find something to help you solve it. Or another great thing that can happen is you can spend some time looking into an issue, you Google it, and you find there's a GitHub issue for a package you're using that causes it. Things like that happen. So Google it, ask your teammates for help. I like to tell a lot of the devs I work with, and it's kind of something that my company does pretty regularly, if you're stuck for more than 15, 20 minutes, just ask someone, because they might be able to give the answer in 2 minutes or point you in a direction. So don't get stuck wasting the day, half a day, hours trying to figure out something if you have somebody you can ask. I know that's something I see a lot with junior developers. People are in a program, they really want to be able to solve it on their own and do it. But sometimes asking for help is the right call to do about pointing in the right direction. Most developers do it in a teaching way. They're going to help you figure out what the problem is, why it's that, how they found that out. Another really important one, not technically related to getting help, but I want to list it on here, is take a break. Go for a walk, go exercise, go have kids, go play with your kids, go play with your pet, go do something else. Take a break from it. You might come back and just have a solution. Continuing to bang your head against your computer and not be able to get anywhere and get stressed out is not going to help you. So take a break. Another really big tip is don't assume. Don't assume it's code, as I've said multiple times. Don't assume it isn't your code. So that can be another mistake you're making is it has to be the network. It has to be the database. There's also a pretty good chance it's your code. So make sure you look at other things, but make sure you also look at your own code. Make sure you're considering that you could have messed something up. We all will write bad code, and then if you're learning, you're getting better, you're gonna look back at your code you wrote 6 months, a year ago, and you're gonna hate it and wonder why you ever wrote it. So your code could definitely be the problem too. You also don't want to assume it's a recent change, which I touched on earlier, is it could be something that's existed for a while and someone just recently ran into a scenario, something changed to cause it. The other thing is you want to make changes. And you want to be careful while you're doing that. Change the minimum required code if possible to fix it. Don't go, you're fixing a bug, especially an urgent bug or something that's high priority. That's not the time to go refactor that method you always want to refactor. It's not the time to clean up that tech debt you want to clean up. File a ticket, do that later. Change this to minimum required code to get the bug working again. The worst thing you can do is delay a bug and cause more bugs by changing more code than you need to. Add test for it. If you don't have tests in your project, highly recommend go get automated testing. It is once you learn how to do it, once you get it set up properly, it is a huge time saver, and you'll love having it when you're solving bugs. Document everything. So document your solution, document what you tried, especially if you know, hey, we have to do a manual fix for a solution. Get it documented. It's going to be useful for you later when you forget in 3 months and the same thing happened. It's also going to be useful for your team. And I already touched on this, but do the refactoring after the fix. If you notice anything wrong, fix it afterwards. Not fix just what is required for that bug. So at this time, thank you everyone for attending. I'll take some questions. If you do want to find me online, I'm at Kevin Hicks SW on most social media. So Twitter, wrong thing. Twitter, Medium. My website is also kevinhicks.software. But I think we still have at least a few minutes here if anyone had any questions. Yeah.
How many developers, junior developers, do you have in your development group?
Where I'm working at, we have above 200 developers, I think, now in total between our DVREs, SREs, BAs, DB, dev stuff. There's about 500 total. Yeah.
You talked about documenting what you try while debugging. Do you have any suggestions for that documentation process based on debugging you do?
Yeah. In the heat of it, you just kind of want to take notes and kind of remember what you're doing. Like I'll do a lot of times of like quick sentence to true summary of this is what I tried, this is what I did, and then at the end if it's something, okay, we know we're going to need to document this, we're going to need to do it in the future. That's when you kind of go back, get anyone that's helping you, anyone involved with it, and come up with a more formal documentation where you get more detailed of like, you know, that's where you might say, go click this, go do that. Yeah.
At the team level, do you have any like practices? So like, for example, you mentioned like if you get stuck for 15 to 20 minutes, go ask help. Is there another like thing to do if asking for help doesn't lead to anything? Like get like a code review or something like that?
Yeah, when you're debugging, code reviews a lot of times will come in afterwards, but yeah, asking for help could consist of you hop on, you start doing some pair programming. You start working on the code together. Sometimes it might be, hey, send me the code you're looking at, especially if something like, say you're writing locally and it's not working. You might send off someone, they might look at it on their own time. Other things is, you just ask them for help. If they can't help you, then you might get multiple people Googling it, multiple people doing research. The other thing is, don't be scared to ask questions on Stack Overflow, other sites. Don't put out any private company information, anything that your company wouldn't want you to do, but you can generalize your problem and put it out there and hopefully get some help. I know we've had to do that in the past. The other thing would be if you're at a big enough company, go outside your team too. Where I work, we have some people that are React experts, we have some people that are C# experts, so the team can't figure it out. We'd be like, hey, let's go ask in the React channel. Maybe they'll be able to help us out. Anything else?
All right, if there's no more questions, thank you so much.